Here you see a summary of the three things that we just talked about in the test for symmetry in the polar coordinates. The first graph on the left has symmetry with respect to the polar axis. The second graph you see has symmetry with respect to the line theta equals pi over 2. The third graph has symmetry with respect to the pole, which is the origin. Symmetry with respect to the pole or the origin is like odd symmetry in rectangular coordinates. And symmetry with respect to the line theta equals pi over 2 is like even symmetry in rectangular coordinates. And here in the box, you see how you test for those types of symmetry. So when you're testing for symmetry in the rectangular coordinate system, all you have to do is plug in a negative x, and then you see whether you get back the original function or the function negative. For testing with polar coordinates, you have to plug in the three different things. So each test is separate. You don't just get to do one thing and see what happens.
You have to test each one separately.
There are different types of categories for polar equations. One category is limacons. They are an animal that is like a snail in the real world. And you can see these with loops or dimples, cardioids, or they might be convex. I do have a chart below that I'm going to show you that gives you different images. And the formulas for those, or the equations, are r equals a plus or minus b cosine theta and r equals a plus or minus b sine theta. The orientation and symmetry of the limacons depends on the trig function, whether you're talking about sine or cosine, and the sign of the term, whether it's plus or minus sine or plus or minus cosine. Roses are of the equation r equals a cosine n theta or r equals a sine n theta, where the petal length is the absolute value of a. You can find the spacing between the petals by taking 2 pi over the number of petals or 360 degrees over the number of petals. In order to find where the petals begin, you want to solve the absolute value of a equals a cosine n theta, or the absolute value of a equals a sine n theta. Lemniscates have the equation either r squared equals a squared cosine 2 theta or r squared equals a squared sine 2 theta, where the lobe has a length of a. And these are figure eights that are symmetric to the polar axis if it's a cosine, or symmetric to the line theta equals pi over 4 if it's sine. We then have spirals. The first spiral has the equation r equals a theta, which is an Archimedean spiral, or r equals e to the a theta, which is a logarithmic spiral. So they start in the origin and they just expand out. In addition, we also have lines. And if you think about this, we know that y equals r sine theta and x equals r cosine theta. So the lines at the bottom here, when you have r equals a over sine theta, that's the line y equals a. R equals a over cosine theta, that's the line x equals a. And then if theta equals 0, that's the line at the x-axis because there is no angle, it's just straight across. If theta equals a, you're going through the origin to whatever the theta angle measure is. And if theta equals pi over 2, that's the y-axis because it's like 90 degrees straight up and down. This graphic isn't very good. I tried to stretch it, but it is in your book. This gives you the different types of polar equations and their graphs. The first one is the line. If you have theta equals 0, that's the x-axis here. If you have theta equals pi over 2, that's the y-axis. Theta at some value of a, whatever the angle is, goes through the origin. And then the horizontal line, because y equals r sine theta, is given by r equals a over sine theta. And the vertical line, because x equals r cosine theta, is given by r equals a over cosine theta. Circles and spirals, remember r equals a is just some circle with that given radius. R equals a cosine theta is a circle centered on the polar axis, and if a is negative, it's flipped across the theta equals pi over 2 line. When you have r equals a sine theta, you have a circle above the polar axis, and if a is negative, it's below the polar axis. And then you have a spiral with r equals a theta. That's the Archimedean spiral. Limacons here, remember they take the form either a plus b cosine theta or a minus b cosine theta, or a plus b sine theta or a minus b sine theta. And the orientation again and symmetry depend on which function it is. Is it sine or cosine? And what is the sign of that? Is it positive or negative? We have a loop here, a cardioid, which looks like it just comes in at a point, a dimpled limacon, and a convex limacon. Roses, you have n petals if n is odd, and you have two n petals if n is even. And to find the spacing between the petals, you take 2 pi over the number of petals, and then to find where the petals begin, you solve either the absolute value of a equals a cosine n theta, or the absolute value of a equals a sine n theta, depending on the equation that you're given. And then lemniscates, here, remember, they are figure eights that either have symmetry on the polar axis or about the line theta equals pi over 4.